Okay, this is CBE 2. So the first question has a cubic equation. So it's some form of x to the third. And we have to mark the vertex. The vertex is -2, -4. So how do I transform x to the third to match -2, -4? So I need to add 2 on the inside because everything on the inside is backwards from what you would expect. Raise that to the third, and then to drop it down 4, I would subtract 4. Now the only question is, what is the constant in front? Well, when we graph parabolas, a basic parabola is over 1, up 1, and then over 2, up 4. Because 1 squared is 1, and 2 squared is 4. Right? What if I had 3x squared? How would I graph that? Would be over 1, up 3, and over 2, and instead of up 4, it would be up 12. So the same idea works here, but now we're cubing instead of squaring. So you can see this is over 1, down 1, and then this is over 2, up 8. So the answer is just a 1. Because it went over 1, down 1 like we would expect, over 1, up 1 like we would expect, and then 2 cubed is 8. So this one is just x plus 2 to the third minus 4. Now I wonder, remind me again how I get a new problem. I have to submit, right? Yeah, I want another of the same problem. So check answer, give up, and then do I submit this? Okay, item 10. And then there should be a submit button somewhere. Next. This is in my way. This is more complicated than it should be. Do I really have to put something in there? How do I submit it? Do I really have to answer them all? Oh, I don't know what I'm doing. Well, I'll just make up my own problem then. Okay. So what if it started here and it looked like this? Anyway, it's going to be up here. And it's going to be somewhere down there. That was bad. So this would be x minus 2 to the third minus 1, and then you'll see that this is over 1 down 2 and over 1 up 2, so that would be a 2. What if I made that negative? Then it's going to look like this. Okay, you guys can handle those, right? So the vertex is the little saddle point. So it's this point right here where the graph comes up and then kind of floats out a little bit. So that will always be the vertex. And then really all you need to know is either this point or this point. Over 1, down 1, over 1, down 2, and over 1, up 2 would put a 2 there. If it went over 1 and up 5, then that would be a 5. If it's upside down, then it would be a negative. All right. Well, now that I broke the system, let's go back to this. Give me, oh, hey. Oh, okay. So this one's quadratic. The vertex is at -4, 2. So it's going to be x plus 4 squared plus 2. And then I just need to figure out this number. And you'll notice over 1, up 1 would make that a 1. Okay? And then over 2, up 4, that's what we would expect with a 1. There is a little bit of a trick. So if this number is a whole number, 2, 3, 4, 5, all you do is over 1, up 4. That would be positive 4. If you go over 1, down 3, that would be negative 3. But if that number is a fraction, it's a little bit harder because when you graph that, let's say that the number was a 1/3, you're not going to be able to tell that that's a 1/3, right? Nope, I drew it wrong. Right? If you had to guess where that is, all you can really do is guess. So with fractions, you can actually make a box that would be over 3, up 3. And if it hits that, then that would be 1/3. If you make a square that's over 4, up 4, and it hits that corner right there, then this would be 1/4. Does that make sense? I don't know if they're going to throw fractions at you, but if they do, that's how you handle them. Okay, number 2. So we need to graph this. So the vertex is going to be 2, -4. So 2, -4 right there. And then it's a parabola that is positive, so it goes up. And it has a 5 as its leading coefficient, so we would go over 1, up 5. And that would be the parabola. Easy enough? Okay. So the graph shown is f of x. We want to graph 3 times f of 2x plus 3. And remember, stuff on the inside works backwards. So we always start from the inside out, and we follow order of operations. So this is step 1, this is step 2, and this is step 3. So if you multiply the x's by 2, you would expect them to get bigger, which means it would expand left and right. But the x's always work backward. Not the x's, but everything on the inside works backwards. +1 moves it left 1. -3 moves it right 3. Timesing by 2 is not going to make it twice as wide. It will make it twice as skinny, or half as wide. So we need to take each one of those points and perform those 3 operations in the correct order. If you do them out of order, it's not going to work. So I need to make all of the x's half as wide. So that would do this, this, and this. And I now have that shape. Okay? I'm going to switch colors. Now we have to perform this. What does a multiply by 2 on the outside do? Oh, is it? Oh, that's step 2. I'm sorry. Thank you. Okay. What does the 3 do? 3 times taller. So the y value here is 2. I'm going to bump it up to 6. The y value here, oh, this is going to mess everything up. I'm sorry. Okay, so we went here, here, here. Now I switch colors. I need to go 3 times taller to 6, 3 times lower. Oh my gosh, negative 12. You guys get what I mean. And then negative 6. So I now have that shape. And then what was the last thing I needed to do? Plus 3. So I add 3 to all of the points. So a 3, and 12 plus 3 is actually going to be 9, and then plus 3. And so you need to draw that shape there. Does that make sense? Okay, so let's, I think I can just turn it off and turn it back on and get a new problem. Okay, so negative 1/2 x minus 3 minus 2. So negative 1/2 f of x minus 3 minus 2. So we have to start on the inside. What does this do? Moves everything right 3. So here, here, and here. Okay. There we go. I go on vacation and my view board is all sorts of messed up. Okay. Now, which step do I do next? Have to follow order of operations. Does multiplication or subtraction come first? Multiplication. So I'm going to do that. What does the negative do? Flips it upside down across the x-axis. What does the 1/2 do? Makes it wider is what it looks like, but the actual movement is shorter. Right? With a parabola, if you cut a parabola in half vertically, it will look wider, but the actual movement is shorter. So we are going to cut the y distance in half. So this point will flip upside down and become half as tall, so it will land right there. And this point will flip upside down and become half as tall, and it will land there. This one flips upside down and becomes half as tall, and it's right there. Okay, and now we subtract 2 from everything. So move this down to here, this down to there, and this down to there, and that is my new graph. Right 3, upside down, half as tall, and down 2. Do you want to see another one? Yeah? Negative 2, x plus 1 plus 2. So negative 2, f of x plus 1 plus 2. All right, we have to start on the inside. What does that do? Left 1. So every point goes left 1. Okay? What does that do? Upside down and twice as tall. Shoot. I don't see enough of the graph. Oh, well, I see what they did. All right. So, okay. So left 1. And then upside down and twice as tall. So my 3 now becomes negative 6. And my 6 now becomes negative 12, which is a little bit off the screen. And then what happens to my 0? Stays exactly in the same place. It can't flip. All right? And then what does that do? Moves everything up 2. So down here I'm at -12. Up 2 would be -10. Right there. So that was a little weird because it went off the screen for a minute, but when we added the 2, it came back and landed on the screen. Okay? Okay, number 4. All right, this is a circle. I don't think you guys have done circles, right? So circles are actually really easy. This is the opposite of the x-coordinate of the center, and this is the opposite of the y-coordinate of the center. And if we take the square root of the constant on the other side, that will tell us the radius. So this circle is left 1, up 3, and then the radius will be the square root of 4, which is 2. So that's what the circle would look like. And it's actually a lot harder to draw circles than you think. Okay, let's do some more of those. So circles are quite easy. Okay, where is the center of this circle? What's the x-coordinate of the center? 0. There's nothing inside the parentheses on the x. What is the y-coordinate of the center? -2. So 0, -2, that's the center. And what's the radius? Sorry, that was a 16. So I take the square root and I get 4. So I just go over 4. 4 and 4. Like that. The x did not have anything inside the parentheses, so the center is just 0. All right, what if I had x plus 3 squared plus y minus 2 squared equals 1? Where's the center of that circle? -3, +2. And what's the radius? 1. Now, how do I know that this is a circle? Anytime you have x squared plus y squared, you have a circle. Then you get what's called a hyperbola. So if it's a minus, then you get this weird, it's like an inverted circle. Now there is a catch to that. Because both of these are 1s, it's a circle. If one was, say, a 4 and one was, say, a 9, then it's actually going to be an egg shape because the x's are not as wide as the y's. So you actually have 2 different radii. You have an x radius and a y radius, and that creates what we call an ellipse, but we're not going to cover ellipses in this class. So as long as the x and the y have the same coefficients, then it's going to be a circle. If they have different coefficients, then it will be an ellipse, but we're not going to cover those. So graphing circles are really easy. Do you want to see another one? Yeah? All right. Where's the vertex? 6, 0. And the radius is 9. So I'd go up 9 and over 9. And I'd get a circle that looks something like that. Okay. Write an equation for the circle that contains the diameter with endpoints at 1, -1, and 3, -3. So I'm going to go back in in here. So 1, -1, and 3, -3. That was cool. All right, so 1, -1 is here, and 3, -3 is there. So what do I know about that circle? Right, the circle has to hit both of those points. How many circles are there that hit both of those points? Actually, quite a few, right? There's this one, but there's this one, and lots of others. But why is that one not correct? It said endpoint, so it has to be a diameter, which restricts us to this circle. So where would the center of that circle be? Right in the middle. And you can see on my graph paper, it's going to be 2, -2. Okay, well, how would I figure that center out without drawing the picture? You could do the distance formula. We will need to do that here in a minute. But how would I find the center? The midpoint formula. Does anybody have the midpoint formula memorized? Me neither. I have to think about it every time. But I know that that midpoint has to be halfway between the x's. Right? If I drew the x's, the midpoint has to be on that line. And then if I drew the y's, it would have to be right there. So all we have to do for the midpoint formula is figure out what number is halfway between 1 and 3. Well, that's easy. You just take the average. 1 plus 3 is 4, divided by 2 is 2. Okay? And then what's halfway between those? Well, I just take the... Oh, did I do that wrong? 1 plus 3 is 4. No, I did that right. Okay, what's halfway between 1 and -3? Oh, did I graph that wrong? Oh, okay. There we go. That makes me feel better. Thank you. So what's halfway between -1 and -3? Just add them together. -4 divided by 2 is -2. So the midpoint formula is actually x2 plus x1 over 2. And again, I have to think about this every time I write it. All it really is the average of the x's and the average of the y's. So the center of any circle with a given diameter will just be the average of the x coordinates and the average of the y coordinates. Okay, so we now know that my circle is x minus 2 plus y plus 2, right? I used this and stuck it in the circle, changed the signs. The positive x became negative, the negative y became positive. Now all I have to do is find the radius. How do we find the radius? The distance formula. Does anybody have the distance formula memorized? Me neither. Do you know why? I know where the distance formula comes from. All it is a right triangle. What is the x portion of that right triangle? 1. What is the y portion of that right triangle? 1. So I use the Pythagorean theorem, which is a formula I do have memorized. A squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared. So 1 plus 1 equals 2. So what's the radius? The square root of 2. So what number do I stick there? The square root of 2 squared, because this is always r squared. So the answer for that is 2. Now that problem was a little overly simplified, so we need to do another one. Okay. So I know the endpoints are 4, -5, and 2, -1. So my center would be the average of the x's. So 4 minus 2 is 2, divided by 2 is 1. Everybody understand that? Add the x's together, divide by 2. And then the average of the y's, 1 minus 5 is -4. -4 divided by 2 is -2. So my equation is x minus 1 to the second, y plus 2 to the second, and then I just need to figure out what is r squared. Well, if I have this point and either point, it doesn't matter. So let's pick this one. How much x travel do I have? How far does the x travel from 1 to 4? So from 1 to 4. The x travel is 3. What is the y travel? From -2 to -5. It also travels 3. Right? So how far is it from edge to center? It's just going to be 3 squared plus 3 squared equals c squared. So 9 plus 9 is 18. And then, do I want to take the square root? No, because as soon as I take the square root and I plug it in the formula, then I'm going to square it again. So it's just an 18. Does that make sense? Do you need to see another one? Yes? Okay. Okay, my center will be the average of the x's. 4 minus 2 is 2, divided by 2 is 1. The average of the y's, -6 plus 0 is -6, divided by 2 is -3. Everybody all right with that? So my formula will be x minus 1 and y plus 3. And now I just need to figure out how far is the center from either of the two endpoints. It doesn't matter which one you pick. So what is the x distance from the center to one of the edges? How far is 1 away from either 4 or -2? 3. And do you see how it doesn't matter which one you pick? It's 3 in both directions. And distance is always positive, so we don't need to worry about direction. So my x direction is 3. What about the y? It's also 3. Let's pretend it was a 4, because the last one was 3 and 3. So now I just need to figure out how far is it that way. 3 squared plus 4 squared equals c squared. That would be 9 plus 16. 25 equals c squared. So in that case, the radius is 5, but I don't care about the size of the radius. I want to know the radius squared. So don't take the square root, just take the 25 and stick it in the formula. Got it? Okay. So the function f is defined, f of x is 2x squared plus 2, and the function g is defined by g of x equals 1 over the square root of x minus 3. So it wants me to find what is f plus g of 4. Now there are two ways to do this. So f plus g of 4 is the same thing as f of 4 plus g of 4. And we did this in chapter 1 of the book. So I could create a new function and then plug 4 into the new function. But the easier way to do it is plug 4 into both old functions and then just add the answers. So if we stick a 4 in there, 16 times 2 is 32. 32 plus 2 is 34. Stick a 4 in there. 4 minus 3 is 1. Square root of 1 is 1. 1 divided by 1 is 1. 1 plus 34 would be 35. Okay? And I recommend you do it that way because if it asks you to multiply or divide, then there's a chance if you put the two functions together and then plug it in, you'll get an answer that doesn't actually work or it does work when it shouldn't. Actually, that's only true with composition, so we'll talk about that here right now. All right, what do compositions do? So it's f of g of 6. So we could take the g function and stick it inside of there and then simplify it. When I get that simplified equation, then I plug in 6. Okay, that will work. But it's much easier to plug the 6 into g and the answer into f. A lot less work, and it will prevent us from making a mistake. So we'll stick the 6 into g in there. 6 minus 3 is 3, and I get 1 over the square root of 3. Oh, that's not nice. Okay. Now I put this in here. 2 times 1 over root 3 squared plus 2. So that would be 2 times 1 times 1 is 1, and root 3 times root 3 is 3. So I get 2 thirds plus 2. How many thirds are there in 2? 6. So 2 thirds plus 6 thirds is 8 thirds. Okay. Now, for composition of functions, you don't want to do it the other way. You do not want to put g into f and then plug it in, because there's a chance that you'll forget about the domain restrictions. So when I'm looking at the function f composed with g, what is its domain? Its domain is the domain of g intersected with the domain of f of g. And the domain of f is ignored, which is really weird, but that is the case. You look at the domain of g, and then you look at the domain of f of g. You don't have to worry about the domain of f. And I think that's going to show up in one of these questions. Okay. Write out the ordered pairs of the function f times g, and then write out the ordered pairs of the function f of g. So this is kind of, let me show you the answer because this is kind of weird. I don't know why they do this. Okay, so the second one is actually easy. So we're going to plug g into f. So we do negative 7. Negative 7 gets turned into 0. And then what does f do to 0? So the domain, maybe I'll write it out this way. This will make more sense. Oh, my heavens. Okay, so this is g. G takes the numbers negative 7, negative 6, negative 3, 0, and 1. And it turns them into 0, 3, negative 2, 2, and then negative 3. Okay? Now, what does f do to the answers of g? So if I pick up the f function and I stick it right here, What does f do to 0? Turns it into -4. Does everybody understand that? Okay. What does f do to 3? There is no 3 in f, right? So it doesn't belong to f of g because there is no 3 in f. Okay? What about -2? It's not in there, so it doesn't go anywhere. What about 2? 2 goes to 0, and -3 goes to -6. Do you guys see how I did that? I did the g function first, and I plugged the answers of g into f, and some of them didn't work. So there is no work done right there. So what does f of g do? It only does 3 things. It takes 7 and goes straight to -4. -7, right there. Okay, and it skips the middleman. All that stuff on the inside gets done without us realizing it. And then 0 gets sent to 0, which is the answer right here. And then 1 gets sent to -6, which is the answer right there. Okay? Do you guys understand that? So we look at what does g do. G is a series of points that turns x's into y's. And then we plug those y's into the f function. And some of them work and some of them don't. And the final answer is just the first part of g and the last part of f. And then we just skip the ones that don't work. Okay. So, what is f times g? Do you see how we get those answers? F times g. You times the y's of the matching x's. Do you see that? Does -6 have a partner in the g function? Yes. Right there. And the answer is just the product of the two y values. So -6, -24. Okay? Does -3 have a partner in the g function? Yes. And then we just multiply those two y values together to get 12. And then 0 matches 0. -4 times 2 is -8. And then 1 matches 1. -2 times -3 is 6. But does 2 have a partner? No. And -7 doesn't have a partner, so those just get left out. Okay. Do you need to see another one of those? A couple say yes. We can do one. That's what I'm here for. Seven. Okay, I'm gonna throw in the wrong answer so that we can see it. Okay, so f of g. Well, let's do this one first. F times g. Is that the same problem? No, it's not. So those two match. So the y value is going to be -6. Those two match. So the y value will be -5. Those two match, and the y value is going to be 0. Those two match, and the y value is going to be -3. Piece of cake. And I don't know why they do that. Like that, I can't see any practical use for that. Maybe it's because I'm not a college professor. Okay, so now we're going to plug g into f. So -7 gets turned into -2, and what does f do to -2? Turns it into 0, so we just skip the middle, and we say -7 jumps to 0. Okay, -6 goes to 3, but there is no 3, so that person is uninvited to the party. Negative 3 goes to 5, but there is no 5, so this person is not invited, which means 3 is not in the domain because it doesn't have a dance partner. Okay. Negative 2 goes to 4, and then 4 goes to 2, so negative 2 goes to 2. And then negative 1 goes to negative 3, and negative 3 goes to 1, so we'll just skip the middleman, 1 to negative 1. I think this test is going to be easier than the last one, right? So far. All right. So we have f, g, and h. Determine f of g of h of 2. What's the easiest way to solve this? Plug 2 into h, plug the answer into g, plug the answer into f. So 2 goes into h. 4 times 2 is 8. 8 minus 12 is negative 4. So we went from 2 to negative 4. And negative 4 gets plugged into g. So we're going to stick it in there. So that's too much thinking this early in the morning. 3 times 4 squared minus 3 times 4 plus 1. Oh, actually, that wasn't as hard as I thought. Okay, so 37. So I get out 37. What do I do with 37? No, did I mess it up? Oh, it's negative 4. I did mess it up. Oh, geez. I messed it up again. 61. Well, it's not a nice number, but whatever. So I got 61. What do I do with 61? Stick it into f, and I get the square root of 61 over 2. 61's prime. Okay. Now, what is g of h of f of x? Well, this I have to plug the functions in. So I'm going to put f into h. So h is 2 times something squared minus 12. And I'm going to stick the square root of x over 2 inside there. You guys all right with that? Sailor? So look at the h function. Okay, so the h function is 2x squared minus 12. So we have 2x squared minus 12. But instead of x, I'm going to put root x over 2. If you want to come sit here, you're welcome to. So 2, what is the square root of x times the square root of x? X. And what is 2 squared would be 4. So that becomes x over 2 minus 12. We good? Now we have to put that into the g function. So the g function is 3 times something squared minus 3 times the same something plus 1. And I'm going to stick this into that. So x over 2 minus 12 and x over 2 minus 12. Not going to be very friendly. So x over 2 minus 12 times x over 2 minus 12. That's going to be x squared over 4 minus 2 copies of negative 12x over 2 plus 144. You guys all right with that? And then minus 3x over 2 plus 36 plus 1. What a mess. Okay. So 3x squared over 4. Those twos cancel. The two negatives cancel. So I get plus 36x plus, I don't know what that is. 144 times 3 is 432 minus 3x over 2 plus 37. Okay. So I need to put the constants and the x's together. So those need to go together. Could I just times everything by 4 to get rid of the fractions? Only if you're looking for the roots. So in this case, we have a function that represents some kind of graph. Multiplying by 4, we'll get rid of the fractions, and it won't change the roots, but it will definitely change the look of the graph. So no, you cannot multiply by 4 and still get the right answer. So 3x squared over 4, that's 72 minus 3 would be 69x over 2 plus 469. I might have done something wrong, but I don't know. Oh, should we check? See how wrong I am. Oh, let's go back. What is the domain of this new function here? Well, all we have to do is look at the domain of f and the domain of the entire thing. Does that have any domain restrictions? No. Okay. Does f have any domain restrictions? So f is root x over 2. Yes. X must be greater than or equal to 0. What two things break domains? Square roots and divide by 0. Okay. And then what if you have a square root in the denominator? Then you have to look at both of them, which means that you cannot do the equal to. So if the square root's in the bottom, then the equal to goes away. All right. Let's see how far off I was. I'm sure that was the right answer. Oh, look at that. Oh, that's good news. No, do you see what they did? They didn't simplify. Yeah, they just stuck it in and left it. And even they didn't even simplify the fraction. That's nice. So she's asking, do we have to put that there? I don't know. Give it a try and see. But that's great news. So they actually didn't simplify anything. I don't think so. It's got a pretty good algebra computing system, but don't do the work if they don't want you to. Yeah, just stick it in. But I mean, look at that. They didn't even simplify that original fraction. So do you have to put the multiplication sign? My guess would be no, but I'm not sure. But we got it right. Okay, number 9. So we have a one-to-one function there. What is the domain? So let's look at this function here. What is the domain of that function? X cannot be what? What single number breaks that function? 1. X cannot be 1. What's the range of that? That's a hard question, right? So let's not answer that question. How will I find the range of that function? It's just going to be the domain of the inverse. So domains are very easy to find. Ranges can be hard. But we're going to do the inverse here. So let's just look at the domain of the inverse, and that will be the range of the original. So we write y equals, no, I will never get used to that. I hope they fix it. X equals 6y plus 6 over 5y minus 5. So let's multiply this by 5y minus 5, and that cancels. So 5xy minus 5x equals 6y plus 6. Now I need to get the y's by themselves and move everything else to the other side. So I will add this over and I will subtract this over. 5xy minus 6y is equal to 5x plus 6. And then this is the hard part. How do I get those y's by themselves? Factor it out. If you have two y's on the same side of the equation, just factor out a y. So we get y times 5x minus 6 equals 5x plus 6. Divide by 5x minus 6. So y is 5x minus 6 over 5x plus 6. Oh, did I do it backwards? Sorry, you're right. So 5x, I missed it over, no I didn't. 5x plus 6 and 5x minus 6. So what is the domain of this function? X cannot be 6/5. What is the range of this function? We have to go back to the domain of the original. The domain of the original is x cannot be 1, but when you switch it over here, it becomes y cannot be 1. So how do I write those in interval notation? Well, this would be negative infinity to 6/5 union with 6/5 to infinity. And then the range would be negative infinity to 1 union with 1 to infinity. Got it? Oh, invert. Oh, geez, this is so easy. Save the easiest one to last. How do you invert a point? Well, the technical way to do it is to reflect it across the line y equals x. But really all you're doing is changing the domain and the range. So this point here is 1, 5. So its inverse would be 5, 1. So right there. And you'll notice, if I could draw my line correctly, it is equidistant from that line. Each points are equidistant. So this point 2, 4 would become 4, 2. And this point 5, 2 would become 2, 5. And then 0, 8 would become 8, 0. Then you connect the dots. Okay. Oh, we're out of time. So I will post this video. There's a video from last year on Canvas. Are they on? Which Canvas are they on? I'm not sure. I'll figure out which Canvas they're on, and then I'll put this video there as well.